In the previous lecture, we looked at data frames and series, and you saw how we can create our data frame using Python data types like lists and dictionaries. So in this lecture, we're going to be looking at indexes in Pandas. Previously, we loaded our sales data in the form of a CSV file and stored that in a variable called data. Now, down at the bottom of our notebook, I'm going to change my cell here to Markdown and then add a comment called indexes and then run the cell. So now, let's have a look of our data. So I'm going to say data.head, then parentheses, and when I execute the cell, then we get a glance of our first 5 rows of our data frame. So the value you see right here are called the index. And indexing in Pandas simply means selecting a particular row and column of data from a data frame. And we saw that in the last video where we used the value of the index to get a particular data from our data frame. So to illustrate with our sales data, I'm going to call my data frame and then pass in the ilog attribute, which stands for integer location. And then in between the square brackets, I'm going to pass in the index value of the row that we want to pull out from our data frame. Let's say 4, and then run the cell. So here we get the data from the 4th row of our data frame. Now, if you look at our data frame, the index is actually in form of integer value. And that's the reason we use the ilog attribute, which stands for integer location. But sometimes we want to work with data frames which its indexes has a name. And your data might come with named indexes in the future. So I'm going to show you how you can set individual names for the index of data frames. For example, instead of the integer value here for our data frame index, we're going to use any of the column here as our data frame index. So to do that, here on where we loaded our data, I'm going to add a comma, then index underscore column equals to single quote, then we're going to pass in the state column and then run the code. Again, I'm going to run this cell to see the first 10 rows of our data frame. Now, as you can see, instead of the integer index we saw previously, we have a data frame with named index. And we can also execute this cell to see the tail of our data frame, which is pretty awesome, right? Now, if we scroll down to the bottom of our notebook, we're going to write the code to access rows from our data frame. So I'm going to update this cell. Then here on this cell is the code we wrote to get rows using integer location. But now we have a named index for our data frame. So instead of the ilog, we remove the I and also get rid of the value 4. Since we are not working with integers, I'm going to add single quote, then the name of the index we're going to grab from our data frame. Let's say California. And when I run the cell, then we see that we got back all the rows of the index California from our data frame. And when we scroll down, we will see all the number of rows with the index California from our data frame, which is about 300 rows. So if I also want to get the rows from a different state using our named index, I'm going to copy the code from my previous cell and then paste on a new cell here. I'm going to pass in Colorado and then run the cell. Now we get back all the rows from our data frame that has the name index Colorado, which, as you can see, it's actually 260 rows of data. So now let me actually show you something even cooler. You see, when we use the ilog attribute using the index name of Colorado and California, then we get back multiple rows of data. But let's say we want to have our rows get its unique name instead of multiple rows with the same name. Then we would have to create an array or list of unique names for each of these rows of data. So to illustrate how this is done, I'm going to collect a sample of 5 rows from our data and set each row to a unique name index. So I'm going to create a variable called new_data and set its value to 5 rows from our data frame, which is going to be data.head. And when I call new_data, then we get back a data frame of 5 rows of data. Now, the next thing I'm going to do is to create the indexes of these 5 rows. In other words, what I'm going to do is to give these 5 rows of data an individual names instead of the integer values we got from Pandas automatically. So I'm going to create a variable called indexes and set it equals to a Python list. Then I'm going to add a single quote, then the first item, which is going to be 1, comma, then single quote, then 2, another comma and single quote, then 3, and then 4, then finally single quote, and then 5. So here is our indexes in the form of a Python list. And to set these indexes to our data frame, I'm going to say new_data, then .set_index. Then in between the parentheses, I'm going to pass in square brackets, then the list of our indexes. Finally, I'm going to add a comma, then say in place equals to true. Then I can also call new_data and also run the cell. Now we can see that the names of our individual indexes have been changed to the names inside our Python list. So now, if we want to access any row from this data frame, I'm going to say new_data and then use the lock attribute, then square brackets, and pass in the name of the index we want to grab from this data frame. So I'm going to add single quote, then pass in the name 2. So when we run the cell, then we get back the second row from our data frame. Again, I can also say new_data, then that's lock, square bracket, and this time we want to grab the 5th row from our data frame and then run the cell. Now we get back the 5th row from our Pandas data frame. And when we actually check to see the type of this data we got from our data frame and then run the cell, then we get back a Pandas series. So this wraps up our tutorial on indexing, and you saw how to use the ilock and the lock attribute to grab data using indexes, and also how to set a particular column as an index of a particular data frame. So in the next lecture, we're going to be looking at filtering rows and columns of data using Pandas. See you in the next lecture. Take care.